in hypothesis test for population proportion, down here in step 4, we're going to need to be able to determine critical values. And it says to use inverse norm or the bottom row of the t-table. Now we learned how to do this a while ago, actually in chapter 7, and then we ran into it again in chapter 9. In particular, the chapter 9 problems all were like two-tailed tests, because a confidence interval is sort of like the inner portion, and the two-tailed test is the outer portion. So we're going to practice finding all of these again, using inverse norm or the bottom row of the t-table. So here's the example. It asks us to find the critical z values, z being the standard normal values, right, for the following situations. And we're going to show calculator entries and appropriately labeled and shaded graphs. Okay, so the first thing we want is a right-tailed test of a single proportion with alpha equal to 0.08. Okay, so let me draw you the picture of that. All right, so there it is. So we have the normal curve drawn. We have 0 in the middle because this is a z curve, and the whole thing about a z curve is it's standard and normal, meaning the center is 0, the standard deviation is 1, and it's a normal curve. Then we have z alpha labeled over here, and yes, you actually have to write that label, and then you have alpha labeled up above it and with an arrow pointing down to it because, well, in this case, a line pointing down to it, but alpha is the area in the entire tail because it's a right-tailed test. And right here. Now, the other thing to keep in mind is that the pictures are just like they are in the inferential statistics packet, the exam notes packet that you get when you get to take your exam. So let me get past all the confidence interval stuff right here. We're trying to do this test right here. So when you look at step 4 right here, I have the picture drawn for you. You are doing a right-tailed test. Oh no, these are backwards. A right-tailed test is the one that I just deleted, and that's a right-tailed test. There we go. That's a left-tailed test. And I just checked in the notes, it's wrong as well. Sorry, I hope none of the rest of them are broken. Left-tailed looks like this picture. Right-tailed looks like this picture because it's the tail on the right. So put big arrows on your notes and arrows on your exam notes packet right here that they have to be switched. So left-tailed looks like this one, right-tailed looks like this one, and you have to follow it. You have to label like I show labeling. So I show Z alpha, you need to show Z alpha. I put alpha up on the top with a little arrow down to it, you have to do the same. I just glanced through the rest of the exam notes packet and it doesn't look like any of the other ones are incorrect, but if they are, we'll find them in the videos. But suffice to say that a right-tailed test has to have the right tail shaded. Okay, so alpha is 0.08. Okay, so we need to be able to find this with inverse norm. Okay, so let me type that up. Now, inverse norm. We haven't used that in a while. Let's look back to chapter 7. When we want to use inverse norm, and we're looking for the z-score ones in particular, so we're trying to find a z-score, you need the left tail area, 0 and 1. Okay, so I know what the right tail area is. The right tail is 0.08. So I need the left tail area. But the left tail area would be 0.92. There we can see it. So the area in the right tail is 0.08. So the area in the left tail is 1 minus 0.08. It's that complement rule from chapter 5 again. And that means that's what we're going to put into inverse norm, 0.92, 0, 1. So I have to grab my calculator and go to number 3, inverse norm, 0.92. And 0 and 1 are the standard issue mean and standard deviation that the calculator thinks about because they're the standard ones. And we get 1.405. So I'm going to go in here, not there, over here, where the box is, and type in 1.405. And that's our answer. Done. Now, the thing about the t-table is that it's an option for you, but it's only an option if 0.08 is in the table, which it's not. So when you look here at the table values that are available to you, 0.20, 0.15, 0.10, and so on, 0.08 is not one of them. And of course, neither is 0.92. And that means you can't use the table on this one because this one is not in the table. The table is great, but it only works for some of them. That's why in the appendix later on, down here it says use inverse norm or the bottom row of the t-table, because sometimes you can't use the bottom row of the t-table, unfortunately. All right, so let's go back to the problem. Now we want alpha to be 0.004 with H1, your alternative hypothesis, written like this. Well, that's a left-tailed test, right? And since it's a left-tailed test, that means that we're going to need a different picture. Test, not left, test, right? And so we're going to need a different picture. We don't want a right-tailed picture, we want a left-tailed picture, which looks something like this. So we have the area in the left tail is 0.004. So let me write that up. There we have it. Okay, so the area in the left tail is 0.004, and that is what I need for inverse norm. So when you look at inverse norm, it needs the left tail area, which I already have. So I don't have to do the subtraction thing that I did on the one above, because the one above was a right-tailed test. So I actually can just go put in 0.004. All right, so let me grab the calculator. Inverse norm, number 3, 0.004. Go down to paste and press enter. Enter. And I get negative 2.652. And that's our answer right there. And of course, make sure that you have this labeled appropriately. Left tail shaded just a little bit, because 0.004 is not very much. It's very tiny. And that marker right there is where the negative Z alpha is, and you have to label it just like they do on this when you get it corrected, when you swap those two graphs. Sorry about that. These could not be found in the table, either A or B, because 0.004 is not a column in the table, and neither is 0.08. So both of those were not possible to be found in the table. But I believe the next one you can, because I wanted to give you at least one of them where you could. Okay, so we're going to do a two-tailed test. Alpha is 0.2. All right, so alpha is 0.20. That's the area in both your tails. But that means that take alpha, cut it in half, and you're going to have 0.10. That's the area in each tail separately. And of course, both of those things mean your center is 0.80, which would have been your confidence level in Chapter 9. Okay, so now we want to be able to find those z-scores. But of course, they're actually the same score. It's just one's positive and one's negative. And that's because there's symmetry in this curve around 0 as your center. So if you find one of them, you sort of have found the other one. All right, so now how could we find it with the calculator? Well, you take negative z alpha over 2, right? It's alpha over 2 now. It's inverse norm 0.1, 0, 0, and 1, right? Because you'd want the area on the left tail. I'm finding this left-hand one here because remember that the decision matrix shows us here that if you want a z-score, you need the left tail area. Okay, so let me grab the calculator. I'm going to go to inverse norm, number 3, 0.1, well 0.10, but 0.1 will work. 0 and 1, paste, and then press enter. And we get negative 1.282. So that one's negative 1.282. So I need to find both of them. I'm looking for both critical values. If you look at your picture right here, you're looking for the two-tailed picture. So you need a negative and a positive, right? So there's two critical values. That's why I put value and then S in parentheses, because sometimes it's one, i.e. one-tailed tests, left-tailed and right-tailed, or one-tailed tests. And sometimes it's two with a two-tailed test. Okay, so if we know this, then we know that Z alpha over 2 plus or minus is equal to plus or minus 1.282. That'll get us both our positive and our negative answers. Oops, 1.282, not 2.652. My fault. 1.282. There we have it. All right, so how could we get this from the table? Well, you could on this one. We haven't been able to for the last couple because I'm trying to get you guys to practice. So if you notice the bottom row of the t-table, do you see how it says Z down there? Right there, it says Z. So we need to go figure out what column we're talking about. But if you remember the picture, it showed us that we had 0.10 as the area in our tails, right? Right here. So that's the column we're going to go to on the table. There you go, labeled it as the column on the t-table. So let me go back to the t-table. I'm going to go to the 0.10 column, which is the fourth one from the left. And I'm going to look right here, and there's the bottom right there, 1.282, just like we said it was. Now it's giving you the positive one because remember that these curves always do area in the right tail. So when we say 0.10 on the table, we're saying the area in the right tail is 0.10. So it's giving us the positive value. But it's okay because once you know one, you know the other. If it was a left-tailed test, you would just make it negative 1.282. Since it's a two-tailed test, you actually say plus or minus 1.282. So you're going to say both of them. All right, we're all done with that, and we've recapped how to find critical z-values for both left-tailed, right-tailed, and two-tailed tests.